All right, so we're back. So this is where we left off right before we went into the CopNet, had a small crash, but you know, these are the things that happen when you're using brand new stuff. Okay, so I'm gonna pop into my CopNet here. And so we'll start on the far screen left. So here, I'm just bringing in my low subdivided object here. So I'm just saying, source low. We could even, like, if like I just found out about this, like I said, I'm learning just like anybody else. You can, if you don't use this external SOP, I could bring in that sub here, and I could set up all that stuff inside of here, so it's all inside of like all the geometry processing and stuff is inside of the CopNet. So you're keeping your, you're keeping your geometry and your texturing or look dev or whatever. You're keeping both of those things clean. So I might do that at a later date, but really now it's just bringing in the low sub here, and I'm also bringing in the low sub over here to go into my preview material like we were last time. So then I'm rasterizing that setup. So remember what the rasterized setup does, it just takes, it stores that original point position into something called @orig_p, and then it flattens everything out from -1 to 1 so that I can rasterize this. So here I'm using my rasterized attributes, so my custom rasterized attributes here, and let's make this a little bit bigger. So, also just learned how to make the text bigger, which is making my old eyes very, very happy. Like I'm doing the same rasterize, custom rasterization that I learned from, I think it was Rohan Dalby put out a video about this. The dude is amazing. I can't believe how fast he works on this stuff. So here I'm getting an empty primitive number, an empty prim UV. I'm getting my closest distance to each one of those, and then I'm grabbing my orig_p, I'm grabbing my UV, I'm grabbing my N, and then I'm also grabbing that distance value that's coming in with that low res. So right now we're looking at that distance value, which in this case, it does kind of look like a displacement map, but it's closest point, and I want projected displacement maps. Actually, I wrote both, and we'll see why I'm kind of leaning more towards the projected displacement maps than the closest distance projection, the displacement maps. So yeah, that's pretty standard stuff. And then here I'm bringing in that sculpted high res that I want to pull that information off of. So basically, what a displacement map is doing is, let's just draw this out. So I have my high res, or let's say this is my low res, and my high res may be doing something like this, like it's just got more detail, right? And then, so basically for each one of these points, right? So this would be a point on, this is orig_p, right? So for each one of those, I am going to shoot a ray along the normal like that. And wherever that ray hits my high res, I'm going to record that, and then I'm going to take this distance. So this is my, we'll call this D or delta, right? So at render time, what will happen is it'll split these things up, right? It'll split everything up. It'll look at the UV map, and it'll look at the displacement map, and it says, hey, at this point, the UV map says move along the normal this distance, which is what I'm recording here. So that's the idea. That's the idea of what's happening. So yeah, so let's get into that. So I'll erase all this. Okay. So this is my rasterized geo, and this is kind of come into, so this is the closest point. We'll talk about that later. And we'll show the difference between those things. But right now I'm using this ray casting method. So much like the rasterized geometry, I'm getting a primitive, I'm getting an empty primitive, right? So I'm getting a empty UV, I'm getting my position that hits when the ray gets projected from the low res to the high res, wherever that hits that geometry, I'm getting that position in space. I don't think I'm using this displace direction anymore. That might be something from testing. So this displace switch, I'll talk about what that is. And then this displace magnitude is literally how far I'm going to move that point once this thing is is rendered, right? So I'm storing this information for later. And then, so this search distance is I'm getting, if we look over here, like I'm taking that distance, right? This cage distance. So basically that's the distance that I got from that ray, and I'm plugging that into here. So I'm going to use that. So I'm going to say for each of these samples, take that cage distance, and right now I'm multiplying it by 5. So I just get a little bit further beyond the surface. So it's a little, and I should probably turn this into a user parameter eventually. Okay, so here's the meat and potatoes. Like this is how this whole thing works. It's like this intersect attribute, or the intersect, not attribute, function, the intersect function. So what the intersect function does is like, it just like most of our other functions, it takes in a geometry to work on. So right now, that is my high res. It takes in a position to start the ray from. So it takes in, so let's just draw this out. It takes in a high res, right? And let's say this is the position of our low res. So it's taking that, and then it's taking a ray direction. So this is my normal here. And so my normal usually goes from 0 to 1, or it always goes from 0 to 1. It's a unit length of 1, right? So what I can do is I can take that direction and I can multiply it by this search dist, which was, this distance. So it should scale out that vector until it hits that point there, or somewhere along those points. So I'm probably scaling the vector way out here with that 5, but I'm making sure that'll hit that high res. Okay, so that's how that works. So this normal times search dist, and then this will return me a hit position, so like that world position in space, and that primitive UV, a lot like the closest distance function does. Okay, so now I need to do a check with this. So this prim is going to give me a number between primitive 0 and however many primitives are on this mesh, on this high res mesh. Now, what happens if it doesn't hit anything? What happens if it's just shoots off into space and never hits anything? This will return a -1, because you can't have a -1 primitive, right? Primitives will always start at 0 and go to however many faces or primitives or whatever that you're working with. So I can check for that. So I can say if this primitive is less than 0, so I'm saying if this is less than 0, if you didn't hit anything, what I'm doing here is I'm just reversing my normal direction and shooting it in the other way. So basically what it's saying is if I don't find anything one direction, turn around and look in the other direction. And if it still doesn't find anything, then it just becomes, then just my distance magnitude stays at 0 and never gets modified. So down here, I'm taking my distance magnitude and I'm taking the length, right? So if this is my original position, so let's say this is my original position, OP, and this is my hit position, HP. I want this length. I want this delta here, because that is my displacement, right? That's what displacement is. It's taking an entity from one point and moving it to another point. You can, like, if you hear about people being displaced from their homes, right? If you were living one place and you were, for some reason, you were displaced from that spot, you were moved from that spot. So that's basically what I'm doing. I'm taking these OP, I'm eventually going to take these OP points and move them to their displaced point. Right, so that's what that is. So basically, to get that distance, I'm getting the vector between the two of them. So all you have to do is subtract your tip from your base. So there's my tip, and I'm subtracting that from my base, and then the length will give me the distance, or the length of that vector. And then my display switch here is what I'm saying. So here I'm basically saying by default my display switch is along my normal, right? It's saying, 1 times that normal is still the same direction. If I'm found something in the opposite direction, I take that display switch and I set it to -1. Okay, so basically I'm taking that length and I'm either leaving it, right, at 1 if I found my high res along the normal direction, or if I found it in the opposite direction, I want to displace inwards, right? So that's why I call this magnitude, like which way it's going. So I'll multiply this. This will either get multiplied by 1 or -1, so it'll flip the direction. And then I just take the displacement here, not just, but I take this displacement that I want to put out, right, over here. This is displacement that's there, right? And I give that displacement magnitude. So it's like functionally not that hard, but mentally, like doing those mental gymnastics is quite difficult. Okay, so so then I just have the switch here because I have a closest distance calculation as well. So we can look at that later. But I think that's kind of a dead end. I may leave it in there for like some very specific use cases. That's why I have the switch in here. But by now right now it's just the switch. It's going through this switch here, and then I'm running this through. So if you look here, this is my new found displacement map. This is looking pretty good. I'm getting that little crease there. I'm getting these eyebrows here, and I'm getting the cheeks and the jowls over here, which is good. So all the median does is it just, if there's any kind of jaggediness, it's kind of like a very specific blur. It's just an anti-aliasing practice, or anti-aliasing, sorry, what I'm looking for, function. So this isn't very aliased, it's pretty smooth, but I usually throw one on there just in case. And you can do 3x3 or 5x5 if you want some more kind of like aggressive anti-aliasing. So I'll leave that at 3x3 because this is still pretty smooth. Okay, so then we take that and we preview it. And that's working pretty well. Like that looks really, really close to what our high res looks like. And so here I just have like a constant going in a base color. And then once again, I'm grabbing that low sub to make sure that I'm not viewing my high res in any way, shape or form. So that's going into my height calculation. So let's go into, let's see, where is it? Normals and displace. So my normal map scale, my height scale, those are both set to 1. If I set this to 0, I'm pretty sure it'll just go back to there. So 1. All right. So that's pretty much it. Like I went a little bit faster than I thought it was going to. So let's so I'll explain why I'm using kind of like this projection setup instead of, so this is the closest distance setup. So, and it's also very similar, which makes this stuff kind of confusing because it looks like it's kind of doing the same thing. So let me switch this over to this closest distance and see why I'm kind of preferring the projection. So when I do closest distance, I'm getting like these really sharp edges, right? Because this is a curve, right? So if it's a curve, then a lot of, if my curve goes like this, right? And let's say that this is my low res here. So these points might be very close to this point, right? So it's almost like a magnifying glass, what's happening with this closest distance like that. So that's why we're getting these kind of like sharp features. You can also look at, if you think about it in from kind of like a light perspective, because light is also just rays moving through space. If you look at the bottom of a pool, right, or a bottom of a shallow pond with waves in it, you get those bright parts. That's because there's this wobble on the water and it's redirecting those light rays down into a focused pattern. So this is the same as that, which is crazy when you really think about it. Like math is math is math. So that's what's happening there. But I'll still walk you through the kind of logic of the vex. So same thing, empty primitive, empty prim UV, hit position, display, displace direction, display switch, and displace magnitude. So pretty much the same recipe. And this is like this one's chimichangas and this one's burritos. So my displacement magnitude now is got from this XYZ dist, right? So the XYZ dist just finds the closest point to the sample point that I'm giving it. So once again, I'm giving it that high res pig head that I've sculpted on. Once again, I'm giving this that original P from the original one. And then I'm just saying, hey, fill in whatever the closest primitive you get and whatever the closest UV you get on that primitive, right? And then the displacement magnitude is how far away that point is from the sampled point. Okay, so now I have to calculate my hit position. I'm using that prim UV. So this is the same tool that I used in my custom rasterizer over here. So I'm saying, give me my high res, return P at primitive and UV, which I grabbed up here. Okay, so I'm taking now that displaced direction, right? And I'm using a normalize now instead of a length, but I'm doing the same thing. I'm taking my hit position and I'm subtracting it from my original position, and that's giving me a vector, and I'm just normalizing that vector. So here's the interesting part, like this displacement switch, how I'm getting this. So my low res point, right, has a direction, has a normal direction. And then I'm also have this displaced direction. So if my displaced direction is in, let's say my displaced direction looks like this. DD, displaced direction. This, if they're pointing in the same direction, should be 1, right? If they're pointing in opposite directions, it'll be -1, right? If they're perpendicular to each other, or no, if they're in the same direction, sorry, they'll be 0. If they're perpendicular, they'll be 1. And if they're in the opposite direction, it'll be -1, right? So I just want to check to see, basically, if it's -1. Because if it's -1, I need to flip my displacement magnitude like I did with the intersects, the ray intersect. So that's what that's doing. It's getting that displacement switch. So I'm saying if displacement switch is less than 0, right? If it's pointing the opposite direction, multiply my displacement magnitude by -1. And then same thing, displace and the displacement magnitude. This was actually the first one I did. I think that's why I still have this displacement direction here. Let's see if I can just get rid of that. And hopefully nothing explodes. Yeah, because I'm not using that at all. So I basically I based this one, like the logic of this position based to this ray based one. So you can use them, and that's why I put them into the switch. You can use either one, but I found the ray based one works way better. Now, once again, this is not a, you might be thinking like, this is really hard. Like, why would I do this? Like, why would I do this when there's still ZBrush, right? Because I'm doing this because it's deepening my understanding of the craft. Like, really, that's the main thing. It's like, can I pull this off? Do I know enough about computer graphics and limited knowledge of mathematics? Can I pull this off? And like, it's not a lot of math. It's more just visualizing what the math is doing. Like, I don't know how to do the math of an array intersect. There is some math in there that does that. I have a book outside that'll tell me, you know, use this number and that number and that number. But like, I don't think I have to get that deep, right? Like I'm floating between artist and technical director zone right here, right? But if you are an artist and you know this stuff, like you're very dangerous. Like you can build yourself a lot of really cool stuff, and then also possibly make some money off of selling that stuff. So okay, so now I have this out displacement. So that's the out image, and then this is just testing said displacement. All right. Okay, I think that's good for now. In the next one, I'll finish this up. I want to take this data out into lobs and just try to render this pig head. So the low res pig head without the subdivision on it. I want to render that. I want to subdivide it and render time, and then I want to apply this displacement map to it. So I'm going to do that in the next lesson. So super exciting, learning a bunch of stuff about everything at this point. And so I don't know if anyone's watching this, but I'm having fun doing it. So I hope you are getting something out of it and having fun doing it too. So I'll see you in the next one.